Hello folks, I am Yashavant Kanetkar and today we propose to start with yet another very important concept in programming, namely recursion. Suppose we have a simple C program wherein within main we make a call to a function printf, following which we make a call to main itself. Can I do this? Well, if you remember, we had said that any function can call any other function. Similarly, if main calls itself, that's perfectly fine. On execution, you'll observe that this results into an infinite loop. Because execution starts with main, printf hi goes to work, then call to main brings the control back to main. Again hi gets printed, again call to main brings us back to main. This goes on indefinite number of times. So in that sense, we have fallen in an infinite loop. Let's look at one more possibility, wherein from main I call some function, maybe fun, and then within body of fun we make a call to the fun itself. At the top we need to have prototype of fun. So execution starts with main, call to fun brings the control to fun, then hi goes to work, call to fun brings the control back here. So fun keeps calling itself, again it becomes an infinite loop. So if main calls itself, it's an infinite loop. If fun calls itself, that's also an infinite loop. In fact, anytime a function calls itself, that function is known as a recursive function, and the process of calling itself, that process is known as recursion. One of the very important techniques that you learn in programming. But a function calling itself and falling in an infinite loop is really not going to serve any useful purpose. You need to somehow or the other make a provision to get outside this infinite loop once meaningful work has been done within that function. Let's see how this can be achieved with the help of a program. What we wish to get is recursive sum of digits of a given number. For that, I'll start with main, ask the user to enter a number, scan its value. And then, if the number is 327, we'll pass that 327 to a function called rsum. R because we are planning to make use of recursion within this rsum function, recursive sum of digits. It should calculate the sum, return it, we'll collect it in some variable sum and then print it out. Needless to say, num and sum have to be defined at the beginning. Let's now try to define this rsum function. Num that we have passed we'll collect in sum int n. And before we actually get the sum of digits, let's look at another parallel theme wherein we wish to get factorial value of a number 4. We know that this is nothing but 4 into 3 into 2 into 1. Out of which 3 into 2 into 1 I can always represent as 3 factorial. So 4 factorial is really 4 into 3 factorial. Where 3 factorial itself is what? 3 into 2 factorial. And 2 factorial is 2 into 1 factorial. Lastly, 1 factorial is nothing but 1 into 0 factorial. We cannot go below 0 because factorial of a negative number is not defined. Point I am trying to make is that 4 factorial is expressible in the form of itself. 4 into 3 factorial, when I say 3 factorial, I am expressing 4 factorial in terms of some other numbers factorial. So any logic which is expressible in the form of itself is something which is programmable using recursion. What applies to 4 factorial equally applies to sum of digits of 327. Sum of digits of 327, I can look upon that as 7 plus sum of digits of 32. The way I say 4 factorial is 4 into 3 factorial, similarly sum of digits of 327 is 7 plus sum of digits of 32. If we are to get that done, first we need to extract the digit. We can do so by saying d equal to n mod 10. And then reduce the number to 32 by saying n divided by 10. 327 divided by 10 will turn out to be 32. So in D we have 7, in n we have 32. So we can say S is equal to D plus R sum of n, 7 plus recursive sum of 32. The moment I make this call to R sum, do we agree that we have now fallen in an infinite loop? So we need to break out of it. To do that, we'll subject this call to a condition saying if n is not equal to 0, then only do this. Otherwise means else. Else do what? If n is 0, then return a 0, because sum of digits of 0 is nothing but 0. And finally do a return s. Then put the closing brace, do define the variable d, also define s. That is how I can obtain recursive sum of digits of 327. This return 0 is perfectly understandable, that if you pass 0 to this scanf, then to R sum 0 will be passed, n will contain 0, 0 not equal to 0 would fail, you should return a 0 because sum of digits of 0 is nothing but 0. What is difficult to understand is the purpose of this return s. What purpose is it serving? You try removing it and try to execute the program, you will find that you get wrong results. Fine? So what we need to do is we need to understand this more carefully. Needless to say, at the top we will have to add prototype declaration of rsum, and we will also have to include stdio.h. That you must do at the beginning. Now, before we try to understand the purpose of that return s, let me make a couple of statements. First of which says that a fresh set of variables is created during every single call. You are calling rsum from main, you are also calling rsum from within rsum. This is the first call, this is the second call. Every single time you are bound to land here. When you land at the definition of rsum, realize that a fresh set of n, d and s would be created, whether call happens from main or whether call happens from within rsum. Fine? Secondly, the variables would die when you return from that call. You land into a function, you create variables. When you go back from that function, the variables would die, they would cease to exist, they would vacate space in memory. Final outcome, of course, is 12. We want to understand how to get sum of digits of 327 as 12. And to do so, all that we need to do is we need to make multiple copies of this rsum function. First copy, one more copy, yet another copy, and still one more copy. From main, the first copy gets called. What is passed is 327. Now let's try to understand the control flow. When it reaches here, n not equal to 0 will be true because n is 327. So condition is true. So d will be how much? 327 mod 10, that is 7. N will be 327 slash 10, that is 32. So s was how much? D plus R sum of n. So 7 plus R sum of 32. And this call to R sum actually brings you here. But for a moment, believe that it takes you to the next copy of R sum. So you are passing 32, you are collecting it in n. 32 not equal to 0 is true. D will be 32 mod 10, that is 2. N will be 32 slash 10, that is 3. So S becomes D plus R sum of n, that is 2 plus R sum of 3. Again there is a call to R sum. Let's say that brings us to the next copy of R sum. We land here with a value 3. So value of n is now 3. 3 not equal to 0 is true. 3 mod 10 will be done. 3 mod 10 is 3. 3 slash 10 is 0. So S becomes 3 plus R sum of 0. This again brings the control where to the next copy with a value 0. So 0 not equal to 0 fails, control goes to else block, return 0 goes to work. Return 0 brings the control to the place from where the call was initiated. It was initiated from here, so control will come back here. So when it comes back with a value 0 because you are returning that 0. 0 will now be added to 3. 3 plus 0 is 3. S will be assigned a value 3. Now that S has been assigned a value 3 means these statements are completely executed. So if block is over, else will be skipped. Control would land where? It would land at return. When it reaches return, S is how much? S is 3. So this return 3 will bring 3 here to the previous call. 3 plus 2 will be done. S will be 5. Now these statements are completed. So else will be skipped. You will reach return S. S contains 5. So 5 will be returned. 5 that you return will be added to 7. 7 plus 5 is 12. S is 12. Now execution of these 3 is over. Else is skipped. You reach return S. You are returning 12. Back to whom? Back to main. Main will collect this 12 and then print it out. Moral for you and me is what? That if you want to understand a recursive function, make multiple copies of it. It becomes easier to keep track of how the control is flowing, what value is being passed, what is being returned. With one single copy, it becomes difficult to understand. With multiple copies, it becomes simpler to understand. Note also the fact that only one copy is created in memory. We created multiple copies only for the sake of understanding the program. In memory, there is only one copy. But with multiple copies, it becomes easier to understand, easier to follow the control flow. So much about how do we go about writing a recursive function. Goodbye, good luck, and thank you.